Okay, so we're now on our third topic. So for the midterms period, so we have the integration by algebraic substitution. Okay, so there are two substitution approach that we can do. One is algebraic substitution, and the other one is trigo substitution. But we'll start with algebraic substitution. So even from the start, we are already doing some substitution as an alternative method in finding the integral using power rule. Okay. It's the same thing in algebraic substitution. The only thing here is you just need to identify which function are you going to set for u, and then one should derive it. Okay, so one should derive it, so you should be able to get the g prime of x dx. And then from there, so we can substitute that one into the integral of fu du. So the idea for the algebraic substitution is sometimes it's difficult to right away. So find the integral of usually a complex function or a complex integrand. So because it doesn't fit to any formula which is available for us, so in finding the integral of a function. So in those cases, so once we know, okay, so what is the function to be substituted in terms of u, and then it resembles to a certain integrand, so which is easier to integrate. Again, so there's no specific rule on which one to set as u, okay? But usually we set u so for the function which is a bit complicated. Okay, so the common one is those functions which involves radical signs. Okay, so that's just one. Although we're not limited to those. Except for radical signs, there are a lot of things that we can do. So we can use power rule. Okay. So we can use inverse trigo. Okay. But we can use algebraic substitution as well. So for example, we have these. So we have 8x plus 1 dx, and then divide it with the square root of 4x minus 3. So as you can see here, the given integrand here, okay, so the base for the given integrand, so which is linear, okay, so 4x minus 3. So if that is linear, so therefore we exclude the inverse trigo formula already here. Okay, how about the power rule? Again, so we're gonna use the power rule. It's because so once we derive 4x minus 3, definitely we'll not be able to get the 8x there. Okay, so but the most feasible one, okay, so to find, okay, so the integral of this given complex integrand, so it's by use of substitution. Okay, so what makes this one complicated is because of the radical sign. So what we're going to do is we're going to let u, okay, so for the function, so which involves a square root, so that would be let u to be equivalent to, so 4x minus 3. And then we square both sides. Okay, so if I will square this, so that is u squared. So the square of square root, that would just be 1. So therefore, that would just give us the 4x minus 3. Then here, so we're going to substitute this 4x, the square root of 4x minus 3 to this u. But then we need to find, okay, so we need to find what's the value of x, and at the same time, we need to find what is the x, because we have to transform everything in terms of u. So to find, okay, so to find the value of u, or to find the value of x, so I'll have u squared and then transpose the negative 3, so that will become plus 3, and then we'll have 4x there. So we divide everything by 4, Okay, so which would cancel that out. So thus we'll have u squared all over 4 and plus 3/4 is equals to x. And then afterwards, we derive. Okay, so to get the value of dx. So this one then so will become 2 times 1/4. The derivative of u squared over 4. So 2 times 1/4, that is 1/2 u. So 2 minus 1 is 1. Then the derivative of 3/4 is 0. So therefore, the derivative of x, that is dx. The derivative of u squared over 4, that is 2 times 1/4, which is 1/2, and then u2 minus 1, that is u. Then 3/4 is 0, derivative of x, it's dx. So now, so we have everything. So we're just going to substitute it now. We're going to transform this one into the 8x. So we'll have 8. Okay, so this is 8. And then multiplied it with x. So what is x? So this is x. Okay, so x is u squared all over 4 plus 3/4. So that is 8x and then plus 1. And then dx, so dx is this. So dx is 1/2 u, or u all over 2. And then divide it with square root of 4x minus 3. Square root of 4x minus 3, it's u. Okay, so this is 8, and then this is x, and this is plus 1, and then we'll have the dx. And the one below, it's the 4x minus 3. So now that we have that, so we just simply simplify this one, right? So integral of, so 8 times u squared over 4, 8 divides 4, that is 2 u squared. And then 8 times 3 over 4, so 8 divides 4 is 2, times 3, that would be plus 6. And plus 1, use u over 2, and divide it with u. So by the way, okay, u, sorry, so that should be u du. u du. And then, so this is u over 2, and then u, I can cancel that out. As once you transpose u, that is 1 over u. 1 over u times u, that is just 1. So thus, we'll just have integral of, that is 2u squared, and plus 7, divide, multiply it with 1/2 du. So finally, we just have u squared, and plus 7 all over 2 du. So u squared plus 7 over 2 du. And from there, so that can be easily integrated. Okay, so after the substitution approach that we did. So we can integrate this one. So right away, so the integral of u squared, that is u cubed all over 2 or 3, and then plus, of course, 7 all over 2u plus c. But then remember, this u again, so u is the square root of 4x minus 3. So 4x minus 3. Simply square root of 4x minus 3, then raise it to cube all over 3, then plus 7 over 2 square root of 4x minus 3 plus c. So we can have that answer, or if you want, so we can make that one as 4x minus 3 raised to 3. That's the same. Divided with 3 So plus 7 all over 2, the square root of 4x minus 3 plus c. That's the answer. Okay, so that's the idea for the substitution method. So we substitute. Okay, so to simplify the given integrand in such a way that it would be easier to integrate it. So that is our first example. So let's have the second example. So for our second example, so we have the integral of y cubed, okay, and then the square root of 2y squared plus 1. So in this case, so we just need to identify, so which will be our u. So again, so just like what we did before, so our u here is the square root of 2y squared plus 1. Then we square both sides, so we'll have u squared, and then that would be 2y squared plus 1. And then from here, I'll have u squared minus 1 will be equal to 2y squared. And then if we derive, okay, so we can derive this one uh, by, so u squared minus 1. So that would be the same as, oh, sorry. So 2u, so 2u du, and then the derivative of this would be, so 2 squared, or 2y squared, so 2 times, so it's 4y dy. Okay. Uh, Let me divide both sides by 4. So I'll just get dy dy. So that would cancel out. So y dy then, so would just be, so u all over 2 du. So let's try to, uh, this should be dy. Sorry, so this should be dy. So what I have here is y dy, okay, and uh, I have uh, 2y squared as well. Okay. But then, so for this given problem, okay, so instead of, we cannot just simply substitute y, okay, to y cubed. Okay, so otherwise, so we'll have du raise it to 3. Okay. So in this case, so we need to divide, okay, so the y cube as a product. So I'll start with 2y squared plus 1. And this is the same as y squared, multiply it with y dy. Right? So y squared times y, so that is y cubed. Okay, so y squared times y, that is y cubed. Do I have y dy? So I have this y dy. Of course, I have this, the square root of 2y squared plus 1. But do I have the y squared? Yes, I have it. Okay. So remember that this is u squared minus 1 all over 2. That's the same as y squared. So u squared minus 1 all over 2 is equals to y squared. So thus, I already have the 3. So therefore, this will be the same as the square root of 2y squared plus 1, that is u, and then y squared, that is u squared minus 1 all over 2. Now multiply yan. And then the y dy, which is u all over 2 du. Multiply natin yun. So u and u, I'll have u squared. Multiply it with u squared minus 1. So ito muna, u and u, that is u squared. And u squared minus 1 is sa baba. So 2 times 2, that is 4 du. So and I can move out 4. So 1/4, I mean. Then the integral of u squared times u squared, that is u to the fourth minus u squared, then du. So now we can integrate it. Okay? So it's just power rule. So 1/4, multiply it with u to the fifth over 5 minus u cube over 3 and plus c. So we just have then as 1 over 20, so u to the fifth minus 1/3 u cubed plus c. But what is u? So u gawin na lang natin siyang ano, no? So 2y squared plus 1, then raise it to 1/2. So that will be 1 over 20, 2y squared plus 1. So 2y squared plus 1 raised to 1/2, and then times raised to 5. So that is 1/2, then raise it to 5. And the other one is 1/3, 2y squared plus 1 raised to 1/2 raised to 3. Let's see. So finally, we'll have 1 over 20, so 2y squared plus 1 raised to 5 all over 2, and minus 1/3, or sorry, 1/12. So 1/12. 1 over 12, 2y squared plus 1 raised to 3 over 2 plus c. So that is our final answer then. So 1 over 20, 2y squared plus 1 raised to 5 over 2, minus 1 over 12, 2y squared plus 1 raised to 3 all over 2 plus c. Okay. So let's have the next one. Okay, so the next is we have x cubed dx over x squared plus 1, and then raise it to 3. So how should we answer this one? So we have x cubed dx over x squared plus 1, raise it to 3. So we don't have a radical sign here. Okay. So, but rather, so we just have x squared plus 1, raise it to 3. So how do we answer this one? So what should be our u? So usually we do not include, okay, so we do not include the exponent unless it is radical, okay, or it's an irrational exponent. Kasi kung include natin yan, then afterwards, we'll have a radical. We don't want, okay, so we don't want to have a radical integrand later on. Okay. So let's say if I'm going to do that, so in this case, I would suggest that u will be x squared. plus 1. Okay. But the problem with this, if we let that u, okay, so to be just x squared plus 1, so once I could have the x squared, so to be, let's say, u minus 1 is equals to x squared. Okay, let's try to do that one. So u, just the x squared plus 1, and then u minus 1 is x squared. So once I derive this one, so u minus 1, its derivative, it's du, and then derivative of x squared, that is 2x dx. And thus, dividing both sides by 2, so du all over 2 is equals to x dx. Okay, so we can do this one. So do not include the rational, or we do not include the exponent anymore unless it is a rational exponent. So the idea here is we want to make this one simpler. So say with this one, the x cubed, so we can have that as simply as x, multiply it with, or x squared, multiply it with x dx, and then divide it with uh, x squared plus 1 raised it to 3. Let's try to see. So x squared is this, so which is u minus 1. And then x dx. Okay, so x squared is u minus 1. So x dx is this, which is du all over 2. And then the x squared plus 1, x squared plus 1, it's u. Then raise it to 3. Okay, so this one will become, I can move out 1/2. Okay. So 1/2, then it will become u minus 1 divided with u cubed du. Right. So we move out 1/2, then u minus 1 over u cubed. And thus we'll have 1/2. Then we separate, so u over u cubed minus 1 over u cubed du. So integrate this. So we make this one 1 minus 3, which is -2. So u -2, and minus u raised to -3. So has to use power rule. So therefore that is 1/2. So u -2 plus 1, it's -1 all over -1. And minus u raised to -3 plus 1, it's -2 all over -2. And thus we have negative, or 1/2, multiply it with -1 all over u. And this one would become positive 1 over 2u squared. And thus I'll have a negative 1 over 2u, and then a positive 1 all over 4u squared. And then what is u? U is x squared plus 1. U is x squared plus 1. So -1 all over 2, x squared plus 1, and plus 1 all over 4, x squared plus 1 squared. Let's see. So that is for the third example. So it's not a radical sign. However, so for integer exponent, so we don't include the integer exponent. Okay, so in setting for the value of u. So otherwise, You say if we're going to do that, so this is what happens. So if we let u to be equivalent to x squared plus 1 raised to 3, so how will you get u? So we need to find the cube root. Okay, so this would become cube root of u equals to x squared plus 1. So it makes things complicated. Okay. So we don't want to do that. Okay, so next we have another one. So the integral of y dy and the fourth root of 1 plus 2y. So how do we set? Okay, so for the value of u. Okay, so for cases like this, so as long as it is a radical sign or uh, the exponent is a rational exponent, so we let u so to be everything. Okay, so which is the 1 plus 2y raised it to 1/4. So therefore, so raising both sides to 4, so u raised to 4, that would be 1 plus 2y. And then, so therefore, u raised to the fourth minus 1 is equals to 2y. And thus, so u raised to the fourth minus 1 all over 2 is equals to y. Once we derive this one, so derivative of u to the fourth all over 2. That would be 4 over 2, which is 2, then u raised to 3. Negative 1/2 is 0, so that would be equal to y dy. Or sorry, dy na lang. So 2u cubed du is equals to dy. So now we substitute. So what is y? It's u to the fourth minus 1 all over 2. That is y. This is our y. dy is this. So 2u cubed du. Then our u, so which is this. So 2 and 2 will cancel out. So we have u cubed and u. So u and u, so this one would become u squared. So therefore, I'll just have u to the fourth minus 1 and multiply it with u squared du. And thus giving us to have u to the sixth minus u squared, then du. So this is u raised to 7 over 7 plus u raised to 3 over 3 plus c. Then u is 1 plus 2y raised to 1/4. This is 1 plus 2y raised to 1/4 and then raise it to 7 over 7 plus 1 plus 2y raised to 1/3, then raised to, raised to 1/4, and then raised to 3 all over 3 plus c. So finally, so we have 1 plus 2y raised to 7 over 4 all over 7 plus 1 plus 2y raised to 3 over 4 all over 3 plus c. So giving us the final answer. So 4, that given example. Okay, so that is, again, so our u, always set u, so with irrational exponent. Okay, so if it's an integer exponent, we exclude the integer exponent. Okay, so similar to this one. So we have 6z minus 1 dz all over the square root of 2z plus 1, raise it to 3. So in cases like this, so it has a rational exponent. Okay? So this one can be rewritten as this. The integral of 6z minus 1 dz all over 2z plus 1 raised to 1 half, okay, and then raise it to 3. Because 2z plus 1 raised to 3, and then the squared is 1 half, so that makes it 3 halves. But again, so in setting for the value of u, we exclude the integer part, the 3. Okay? So we only take the raised to 1 half. Okay? So to make it an integer exponent later on. So that is why what we will be setting, so for our u here, so u will just be the 2z plus 1 raised to 1 half. And square on both sides, so u squared will be 2z plus 1. So u squared minus 1 then will be 2z. So we divide both sides by 2. So we'll have u squared minus 1 all over 2 equals to z. And we derive. So u squared all over 2, so its derivative will be 2u all over 2, which is just u du. Then derivative of negative 1 half, that is 0, is equals to dz. So dz then is equals to u du. Okay, remember, I'm just dividing this one, okay? So u squared minus 1 half. So derivative of this is 0. U squared, so that is 2 times u all over 2, which is just u du. Okay? So now that we have everything, so I'll be substituting. So integral of 6z. So what is z? So that is z. So z is u squared minus 1 all over 2. Then minus 1. So 6z. So our z is u squared minus 1 all over 2 minus 1. And then dz is u du. Then divide it with, this is u. Right? So raise to 1 half, it's u. Then raise it to 3, that is u cubed. So simplifying this, so it will give us, so 6 over 2, right? So that's u squared over 6 over 2, that is 3. So 3u squared minus 3. Then minus 1. By the way, u will cancel out, but remains 2 there. All over u over u squared. So u squared, then du. So which is the same as 3u squared minus 4 all over u squared du, so which is integral of, so 3 minus 4, the u squared will become u negative 2, and the last will have 3u, so negative 4 u raised to negative 2 plus 1, it's negative 1 all over negative 1 plus c, or 3u will become plus 4 all over u plus c. So negative and negative, so positive, then u negative 1 will become u at the bottom part. And that's, so for final answer, so u is So our u, so 2z plus 1 raised to 1 half. 2z plus 1 raised to 1 half. 2z plus 1 raised to 1 half. So we can do that one as 2z plus 1 raised to 1 half and plus 4 over 2z plus 1 raised to 1 half plus c. If you want to simplify it, we can simplify it. But okay, this is okay already. So let's have our last example. So algebraic substitution is not limited to algebraic functions. Okay, so sometimes, so we can use algebraic substitution, okay, so for trigo functions as well, which involves, again, a radical sign. Okay? So we have the square root of 1 plus sine theta. Okay? So this is not an inverse trigo, so definitely it won't be a power formula because we won't be able to get sine squared theta cosine theta there. Okay, but rather, so similar with what we're doing before, so we let u so to be equivalent to the square root of 1 plus sine theta. Or we could make that one as 1 plus sine theta raised to 1 half. So u squared will be 1 plus sine theta. And then u squared minus 1 is equivalent to sine theta. So once we derive this one, so that is 2u. Derivative of sine is cosine theta d theta. So we can now substitute. Okay. So we'll start with sine squared theta. So we have sine theta, which is u squared minus 1. However, there's a square there. So the sine squared theta, it's u squared minus 1 raised to 2. Then cosine theta d theta is the cosine theta d theta. So 2u du. So multiplied with 2u du. And divide it with the square root of 1 plus sine theta, which is just u. So this would cancel out. I'll have 2, then u squared minus 1 raised to 2 du. Then so we can expand. So this one will become u to the fourth minus 2 u squared then plus 1 du. So we distribute, so 2u to the fourth minus 4 u squared plus 2 du. So we integrate, that is 2 u to the fifth or over 5 and minus 4 2 cubed over 3 and plus 2u. But then our u is 1 plus sine theta. Okay, so but u is 1 plus sine theta raised to 1 half. So therefore that would be 2 over 5, 1 plus sine theta. So 1 half times 5, it's 5 all over 2. And minus 4 over 3, 1 plus sine theta. So 1 half times 3, that is 3 all over 2. And plus 2, 1 plus sine theta raised to 1 half. Let's see. And that's it. So that is everything, okay, so about algebraic substitution. So by the way, the examples, so we're just, the reference for our example is matalino.com. Okay, so I just borrowed, okay, so those examples that I had solved at that site. And then the other one was taken on your module. The last one, example number 6, was taken on your watching. So I do not own nor formulated any of those examples. So I just solved them. So using those references. Okay, good day.